For our videos, the procedures are the same for LIMDEP and NLOGIT, so I'll just refer to LIMDEP. This video will illustrate the use of panel data using one of the datasets distributed with the program. From the File menu, let's select Open Project, find the dairy project file, and double-click it. To view the data, let's open the data editor by double-clicking any variable name in the project window or clicking the icon on the toolbar. LIMDEP contains many procedures and models for using panel data. All of the dozens of models provide numerous panel data forms, such as fixed and random effects and random parameters. There are also numerous data handling features, such as create transformations, that are specifically for panel data. This video will illustrate a few of these. We'll start with fitting models with panel data. The dairy data we are looking at here are a panel with 247 farms and 6 years. Panel data analysis involves 2 steps. First, globally specify the panel. Second, build the type of panel model desired into the model command. Let's open an editing window. For the first step, we use the set panel command. The format is set panel, group equals the identification variable, PDS equals the name of a variable that the program will create. Notice that the first variable in the dataset is called farm, and it is a farm ID number. For our example, set panel, group equals farm, PDS equals TI. This command creates the variable TI, which gives the number of observations in the group for each group. You can call the variable anything you wish. At this point, TI always equals 6. This might change. For example, if you use only years 1993 and 1994, at that point, TI will become 2. You don't need to worry about this. LIMDEP handles this internally. You need only set the panel once. The next step is the modeling step. To fit a regression of YIT on 1, X1, X2, X3, and X4, you would use the following regression command that specifies the LHS and RHS variables accordingly. Adding panel to the command allows a panel data treatment. To fit a random effects panel data regression, add panel and random effects to the command. To fit a fixed effects model instead, we would specify fixed effects instead of random effects. In many cases, it is necessary to have some differences across models in the way that the panel model is specified. For example, let's use the frontier command to fit a fixed effects stochastic frontier model. First, specify the command without the panel specification. Then add the panel and FEM specification for fixed effects. Note we have to use the specification FEM instead of fixed effects with frontier. Panel data formats are used for all of the 50 or more basic model forms in LIMDEP. The panel models include random and fixed effects, latent class, random parameters, and sometimes several others specific to a given model. There are several create functions that use panel data as well. One that you will probably want to use creates the group means of variables. For example, this creates the new variable x bar I. For example, you could use group means to carry out a WU test for random versus fixed effects. Those are some of the basic features of panel data modeling. Thanks for watching.